Well, welcome to Chapter 2. We're going to be dealing with number lines, equivalencies, and fractions, your favorite probably. So these are the different sections we're going to have. Section 1, which we're going to do now, is exploring equivalencies with number lines. Section 2 is fraction equivalencies. Section 3 is fractions to decimals, decimals to fractions. Section 4 is intuiting magnitude of rational numbers. And Section 5, you can't add cats and dogs, but you can add fractions. There's 3 worksheets here. These 2 actually do not exist. So there's 3 Excel problems, which I will go over. Just converting algebra equations to Excel formulas, bike distance travel, and how long you to drive to your vacation destiny. So, welcome to Chapter 2. Okay, this is the reading section, which I hope you read, but I want to go over because there's actually a lot here. It says, recall that numbers are used to represent the amount of some quantity, like how many items or how much of something. We're going to use number lines to illustrate our number. Each number line will have units to represent the quantity. In other words, things out in the, you don't see like up in the sky, like here's a cloud. Up in the sky, you say, oh, there's a 9 up in the sky. No. You associate a number with something. And here's an example, right? Use the number line to illustrate the alpacas in the picture. Well, here's the number line. It has a 0 and a 1, and then each number subsequently is spaced the same distance. Number lines have a 0 and a 1, and the distance between these numbers is called the unit length or magnitude. So this is arbitrary how far apart 0 is from 1, and 1 is the same distance from 2, but it is at least consistent. As soon as the unit length is determined, you can place other counting numbers on the line equally spaced apart. Different, and this is an important one, different number lines can represent the same underlying quantity with different units. And we're going to get to that. But these units here are alpacos, because that's what we're counting. And we counted 3 of them. So the number is 3 and the units is alpacos. So we have 3 alpacos. So here in our example, we have 2 number lines. The first number line, the unit, is roses. And the second number line, the unit is dozens. So here is 1 dozen, 2 dozen roses. And here's 1, 2, 3, all the way to 12. So there's 12 roses, and notice that 12 roses is equivalent to 1 dozen. Numbers that line up vertically on the number line represent the same underlying quantity. Now obviously 1 doesn't equal 12, but I think you know that 1 dozen equals 12 roses. So this is a very important concept. Note how the number 1 and 1 dozen lines up to 12 roses, so 1 dozen is equivalent to 12 roses. Notice how the number 1 in this number line represents a different thing or unit than the number 1 on this number line. But these line up vertically, so this 1 and this 12 are equivalent. And we use the symbol with 3 bars to denote that it is equivalent to. indicating the same quantity represented by different units. This essentially means equal to, but it draws our attention to the different units, as in 1 foot is equivalent to 12 inches. We normally would just write 1 foot equals 12 inches, which is fine, but this at least draws our attention to we're dealing with different units. So this end you're responsible for turning in because it's 2.2a. So it says draw 2 number lines representing the quantity of milk using units of gallons, quarts, and pints. The relationship is 1 to 4 to 8. That means gallons, quarts, pints. It follows the same pattern, right? So let me get quarts if I can draw a straight line. I'm going to start with 0. I'm going to go all the way, not very straight, but to 4 quarts. And then I'm going to put in 1, 2, 3, 4 quarts, equally spaced apart. Now let's see if I can draw a better line for pints. And that would be 8 pints, right? And these line up vertically, they are equivalent. So let me put in 8 here. 1, 2, 3, 4, 5, 6, 7, 8 pints. So now it says list the equivalencies. Well, I'm going to list some of them here. Here's an equivalency. 1 quart equals 2 pints. I'm going to abbreviate. Here's another equivalency. 2 quarts is equivalent to 4 pints. Yes, I am using the equivalent symbol and the equal symbol interchangeably because we do that, right? And here I have 3 quarts is equivalent to 6 pints. See, numbers that line up vertically have the same underlying quantity, right? And finally here I have 1 gallon equals 4 quarts equals 8 pints. And so there are the equivalencies. So here's your thought question. Consider the numbers that are usually associated with using. Considering the numbers, if you include units, is it ever possible that 3 does not equal 3? Well, sure. 3 gallons, just from this example, does not equal 3 quarts. I'll just put that here. 3 gallons does not equal 3 quarts. Or I could say $3 bills does not equal 3 quarters. Does 3 of something ever equal 12 of something else? And we can see from this that if I had from up here 3 gallons, if I triple the amount of gallons, I would triple the amount of quarts. So yes, and this is kind of a key idea here. Okay, we're going to divide 1 gallon into quarts, pints, and ounces. The relationship is here. Gallons, quarts, pints, ounces, and it's also here. So these things are lined up vertically. These represent the same quantity. In other words, there's 4 quarts equals 1 gallon, 128 ounces equals 4 quarts, etc. So I'm going to drop in the numbers here. This is cut into 4s. this is cut into eighths. Equally spaced apart. And how am I going to do this? Well, how about 128 divided by 8 equal parts would be 16 here. And if I so 1 pint equals 16 ounces. They're lined up vertically. So if I double the amount of pints, I would have to double the amount of ounces. Or if I triple the amount of pints from 1 to 3, I'd have to triple the amount of ounces. Or each eighth adds 16 more ounces. And so there you go. So the equivalencies are everything that lines up vertically. Here's one here. 1 quart is the same as 2 pints is the same as 32 ounces. That's lined up vertically. 5 pints is the same as 80 ounces. That's lined up vertically. 3 quarts is the same as 6 pints is the same as 96 ounces. Okay, so there are some equivalencies I listed. Gallons, quarts, pints, and ounces are measurements of volume. Explain why a cubic inch is also a measurement of volume. Well, there is 1 inch. There is 1 square inch. And 1 cubic inch, I'm going to try to grab that. And I did, and I put it right here. It's a cube, 1 inch by 1 inch by 1 inch. Looks a little bit more rectangular, but I try to make it cube. And a cube you can fill up with stuff, right? So it is volume. So length, area, volume. Inch, square inch, cubic inch. So this is 2.4, but you don't have to turn in. It's just supposed to read ahead of time. And I'm just going to go over this just a teeny bit, just to explain one thing that's happening here. So you could divide one class of 24 children into 2 equal teams. Draw number lines for classes, children, teams, and halves. So we're introducing halves, which is a fraction, right? Which is something over 2 halves, right? 1 over 2. That's 2 halves. 1 half, that's 2 halves. That's 3 halves, right? So these are all equivalent here because they're lined up vertically. 1 half the class is the same as 1. That's the unit. That's the magnitude. That's how many you have of the unit here. Half. So these are units. So at any kind of a fraction, the denominator is the unit. And so here's an equivalency here. Notice that 2 halves represents the whole class. And it also represents 24 children, right? Or you could put this on pause and fill in, because this one, it's an A, 2.4A, so you're responsible for it. You can put it on pause and fill in what I did, and this is just from the last example. So I'm just going to ask you a couple things here. What goes here? What goes here? And what goes here? Those are the 3 things. Well, if you guessed that a 1 goes here because that's 1, and these are the units. This is what they are. and that's one of the unit halves. What goes here? Well, this is 1/2, because 1's here, and half of 1 is 1/2. And what goes here? Or ounces. And if you guessed, you're taking 128 and dividing it by 8 equal parts. By the way, that's the same as taking 128 and multiplying it by 1/8, or finding 1/8 of 128. This is equivalent to this. It's a difficult one, I know. But that would be 16. Okay, so list the equivalencies for half a gallon. We're going to have 2 quarts. And that's going to equal or equivalent to 4 pints, which is equivalent to 64 ounces, which is equivalent to 1/2. List the equivalencies for 1 gallon. Well, they're all listed right here, right? Anything that lines up vertically, like that and like that, are equivalent, meaning they have the same underlying value, despite having different numbers, right? So this would just be 4 quarts. I'm just going to put a Q. 8 pints, put a P. 128 ounces, put an OZ, and 2 halves. How many ounces, pints, and quarts are in 3 halves? Well, if there's, let's just take it with ounces first. If, here's an equivalency, 1/2 is 64 ounces. So we got 1/2 equals 64 ounces. So if I triple this to 3 halves, I'm going to triple this, which is just 64 times 3, or 64 plus 64 plus 64, right? Be 192 ounces. So that's what 3 halves is in terms of ounces. And pints, 1/2 is 4 pints. I'm going to write it like this. 1/2 equals 4 pints. So if I triple the amount of halves to 3 halves, I'm going to triple the amount of pints to 12 pints. So there's the equivalency for pints. For quarts, 1/2 equals 2 quarts. So I'll put it over here. 1/2 is 2 quarts. So if I triple this to 3 halves, I'm going to triple this to 6 quarts. And for our thought question, what do you think goes here? Now, some of you might be tempted to say, well, I can change this fraction into another fraction, like an equivalent fraction, but what do I multiply 2 over 2 by to get a 3 here? But then you're missing something. You're missing this fundamental idea. 2 halves is the same as 3/3, because they're both equal to 1. So our last question. I skipped 2.5 for you to read, and I'm going to the one you need to hand in, 2.5a. Divide 1 hour into minutes and tenths. The fact that we have 60 minutes and 1 hour is a vestige of what number system? Remember? Starts with a B. The Babylonians. They had a base 60 system. So these are going to bring in decimals ahead of time, so don't worry about it that much. And it's going to just, a lot of students get this messed up, like 0.7 hours is how many minutes, right? So these are tenths, so I'm just going to put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths. Hopefully you know that 2 halves is the same as 3/3 is the same as 10 tenths. Right? So this is just the whole, which is 1 hour. So the hours have been cut into tenths, and I'm going to write them this way. 0.1, 0.2, 0.3, 0.4, right? 0.4 is the same as 4 tenths. 0.5, 0.6, 0.7, 0.8, 0.9, and finally 1. So that's the relationship between the decimal system, right? 0.1 is the same thing as 1/10, which we are now writing as 1/10. So 60 minutes, I got to cut those into 10 equal pieces. So I can take 60 minutes and I can find 1/10 of 60 minutes. And if you recall, that is exactly the same thing as taking 60 minutes and dividing it by 10, which you would get 6. So 1/10 is 6 minutes. If I double the amount of tenths, I'm going to double the amount of minutes. I'm going to keep adding 6, or if I triple the amount of tenths, I can triple the amount of minutes. Hopefully you're understanding this. There we go. So 3/10 of an hour, or 3/10, which is right here, is equivalent to 18 minutes. 7/10 of an hour, or 7/10, right here, is equivalent to 42 minutes. And 8.5 tenths, which is going to be between 8 and 9, right? Is going to be how many minutes here? It's going to be halfway between 54 and 48. 54 minus 48 would be 6, so it would be 3, so it would be 51 minutes. Okay, this is an important one. Students have a lot of trouble going from minutes, parts of an hour to minutes. Given 1 hour as a thought question equals 60 minutes, how do you mathematically convert hours to minutes? So if I had 1 hour is 60 minutes, then 2 hours, if I double the hours, I double the minutes. So how am I going from 1 to 60 or 2 to 120? And the answer is multiply by 6. So even 1/10 of an hour multiplied by 60. So let's say I had 0.4 hours. If I multiplied that by 60, I would get 24 minutes. And let's look up here. There's 4/10 of an hour, and there's the 24 minutes. I could also use a fraction instead of a decimal to multiply. 4/10 of an hour times 60 minutes times 60. And I'm going to get 60 divided by 10 is 6. 6 times 4 is 24. This is the next chapter, this kind of multiplication. But to go from hours to minutes, you multiply by 60. How do you go from minutes to hours? Well, how about divide by 60? And that's how you do that. Okay, so here's what you're taking pictures of, these pages. And we'll go through and see if there's anything. This is all done in the video. All these were completely done. All the 2.4a, 2.5a. And now here we hit your homework. And I'm going to do a couple of these just to be clear, because this is important. So I'll do a little bit of 1. 2 you should be able to do easily on your own. And 3, yeah, that should be pretty easy too. And 4, I'll do a little bit on 4 for you here in a second. So here you want to determine the unit and how many you have of the unit. So the first one's an example, 3 alpacas. The unit is alpacas, and how many you have is 3. So they could be pretty simple. Now 3 halves, the unit is halves. And how many you have is 3. All right, this 32 is actually 2 units. It's 10s and 1s. So you have 3 10s and 1 and 2 1s. 8 tenths, again, is a fraction. All fractions, the how many they've been cut into is the unit. So that's tenths. And how many you have of them is 8. So you can fill the rest of it out, but that's an example of all numbers are in context. And the context is the unit. And the number of the amount that you have is just how much of each, right? So here's problem 4, which is a typical acre of New England forest contains 3,500 trees. 60% are hardwoods, meaning like oak, maple, birch, and 40% are softwoods, meaning like pine, spruce. So there's 1 acre, there's the equivalency there. And so would they want to know, fill in the blanks for the number of trees, and then use that information. So I'll just get you started, right? There's acres, trees, and fifths. So if you take 3,500 and do what to it, you'll get 1/5. And then 2/5 is twice as many as 1/5. This 1/2 is falling between 2 and 3, so it's like 2.5 fifths. So as far as how many hardwoods you have, the hardwoods are 60%. So we need to look at 60%. 60%, all percentages. 60% means 60 over 100. Now let's reduce that fraction, which we haven't gotten to, but those cancel, right? Because it's just, and then you have 6/10. And you can divide the top by 2 and the bottom by 2, and you get 3/5. So I don't expect you to know that. It's sort of a preview of fractions, right? So 3/5 are hardwoods. That leaves 2/5 for softwoods. So from there, I think you can probably figure it out.